Hey there! So, let's talk about a common problem that many people face when analyzing algorithms. The problem revolves around understanding the time complexity of a Fibonacci algorithm. You see, there's this algorithm that calculates the Fibonacci sequence, and it can be a bit confusing to determine just how efficient it is. In the solution provided, it's explained that there are different models for computational complexity. The solution clarifies that the Wikipedia page referenced uses the arithmetic complexity model, where arithmetic operations are assumed to happen in constant time. However, as Fibonacci numbers grow quickly, the use of dynamic big integer types like Python becomes necessary. In this model, arithmetic operations like addition have a time complexity that is linear with the size of the numbers involved. So, to sum it up, the Fibonacci algorithm's time complexity can be a bit tricky to grasp. While the arithmetic complexity model assumes constant time arithmetic operations, the reality is that the rapidly growing Fibonacci numbers necessitate a shift to a bit complexity model with dynamic integer types. This adjustment accounts for the linear time complexity of arithmetic operations. And with that, we've demystified the time complexity of the Fibonacci algorithm. Thanks for watching, and don't forget to subscribe, like, and drop a comment below with your thoughts, and maybe a Fibonacci joke or two.